Hi friends, welcome back to our YouTube channel. Today we have to discuss about applications of logic microoperations on computer architecture course, computer organization course, computer organization and architecture course. First of all, what is the use of logic microoperations? Logic microoperations are used for performing bit manipulation operations on the data stored in registers. That means whatever the data that is stored in the registers, on that data we have to perform bit manipulation operations only. For that purpose, we have to use logic microoperations. There are 16 logic microoperations are there. How to implement that 16 logic microoperations using hardware implementation that are discussed in the previous video. If anybody wants, please refer the previous video. Now, what are the applications of logic microoperations are there? There are 6 logic applications of logic microoperations are there. First one is selective set, second one is selective complement, third one is selective clear, fourth one is mask operation, fifth one is insert operation, and the sixth one is clear operation. So first one is selective set operation. Selective set operation is nothing but we are setting some selective bits to value 1. How it can be performed? Suppose I am taking a 1010 that is stored in a register A. Before performing selective set operation, register A contains 1010. Next one, 1100 is stored in a register B. Now, how to perform the selective set operation? Okay, to perform the selective set operation, identifying the bit 1 in register B only. Okay, here in register B, here bit 1 is there, here bit 1 is there. The corresponding bits in register A can be set to 1. Okay, here 1 is there. The corresponding bit in register A is 0. That can be set as 1. Here 1 is there. The corresponding bit in register A is also 1. So there is no change at all. Next one. In register B, any 0 bit is there. The corresponding bit in register A does not change. Here 0 is there. The corresponding bit in register A is 1. There is no change at all. Here 0 is there. The corresponding bit in register A is 0. There is no change at all. Here we have to consider only bit 1 in register B. The corresponding bit in register A can be set. Okay. Here 1 is there. The corresponding bit in register A can be set. Already it is 1 is there. There is no change at all. Here 1 is there. The corresponding bit in register A is 0. So 0 can be set by 1. Okay. So this is after performing selective set. Selective set. So register A contains 1010, 1110. Okay, so this is the selective set operation. Next one is selective complement operation. So that means we have to complement some selective bits. 0, if it is 0, 0 can be complemented as 1. If it is 1, it is complemented as a 0. Okay, how it can be performed? So suppose register A contains 1010. Before performing selective complement operation. Register B contains 1100. Now, how to perform the selective complement operation? To perform the selective complement operation, identifying bit 1 in register B. Here, 2 1s are there. Okay. For this one in register B, the corresponding bit in register A is 1. So, 1 is complemented as 0. Next. For this one in register B, the corresponding bit in register A is 0. It is complemented as 1. Next, 0 bits in register B, the corresponding bit in register A does not change. Here 0 is there in register B, the corresponding bit in register A is 1. There is no change at all. Here 0 is there, the corresponding bit in register A is also 0. There is no change at all. Okay, here we have to consider only bit 1 in register B. The corresponding bit in register A can be complemented. Suppose bit 0 in register B is there, the corresponding bit in register A does not change. Okay, so after performing selective complement, register A contains 0110. Okay. Here register B can be called as logic operand. Here also register B is logic operand. I hope you are understanding selective set and selective complement. Next, third one is selective clear. Selective clear is nothing but we are clearing the selective bits to 0. How it can be performed? Suppose register A contains 1010. Before performing selective clear operation. Register B contains 1100. So it can be called as logic operand. How to perform the selective clear operation? To perform the selective clear operation, identifying bit 1 in a register B, the corresponding bit in register A can be cleared to 0. Okay. Here bit 1 is there. The corresponding bit in register A is 1. It can be cleared to 0. Here 1 is there in register B. The corresponding bit in register A is 0. Already it is clear, so we do not change that bit. Next one, here bit 0 is there in register B. the corresponding bit in register A does not change. Here 0 is there, the corresponding bit in register A does not change. So after performing selective clear, register A contains 0, 0, 1, 0. Okay. In these three operations, we have to consider only bit 1 in register B. The corresponding bits in register A can be set as 1 in selective set operation, can be set as complemented bit in selective complement operation, can be clear to 0 in selective clear operation. By observing these three examples, we have to consider only in bit 1 in register B. The corresponding bits in register A can be clear to 0 in selective clear operation, can be complemented in selective complement operation, can be set as 1 in selective set operation. In register B, any 0 bit is there. The corresponding bit in register A does not change. Okay, so these three operations. Next, we can go for fourth operation, so mask operation. How can we perform the mask operation? In the mask operation, we have to consider only bit 0 in register B. The corresponding bit in register A can be clear to 0. If any bit 1 is there in register B, the corresponding bit in register A does not change. Okay. Suppose register A contains 1, 0, 1, 0. So before performing mask operation. Next, register B contains 1, 1, 0, 0. So this can be taken as logic operand. How to perform the clear mask operation? Okay. To perform the mask operation, first identifying bit 0 in register B. Here 0 is there, here 0 is there. So 0 bit in register B, the corresponding bit in register A can be clear to 0. Next, here bit 0 is there in register B, the corresponding bit in register A can be masked, that means can be cleared to 0. Already it is 0 is there is no change at all. Next, bit 1 in register B, the corresponding bit in register A does not change. So 1 is same. Here bit 1 in register B is there, the corresponding bit in register A does not change. Therefore, here two 1s are there, the corresponding bit in register A is 1, 0. There is no change at all. Here we have to consider only bit 0 in register B. The corresponding bit in register A can be clear to 0. Okay, this is the result after performing mask operation. After performing mask operation, register A contains 1, 1 0 1 0. So this is the mask operation. Next we can go for fifth operation. The fifth operation is insert operation. So insert operation is nothing but combination of mask operation and OR operation. So it can be called as mask plus OR operation. Mask plus OR operation. Okay. So how it can be performed? Okay. Suppose register A contains 0 1 1 0 1 0 1 0. So 8-bit information stored in register A. Now I want to insert 1001 in the place of 0110. That means we want to insert 1001 in the place of 0110. After inserting 1001 in the place of 0110, we are getting the information as 1001 1010. This is called as after performing insert operation. So this is the result we are getting in register A. This operation can be called as insert operation. To perform that insert operation, first we have to perform the mask operation. Next we have to perform the OR operation. Okay. So in register A contains 0 1 1 0 1 0 1 0. So this is register A. Next one, here register B contains here 0 0 0 0 1 1 1 1. First we have to perform the mask operation. In the mask operation, we have to consider only 0 bit. We have to consider only 0 bit. Okay. Here 0 is there in register B. The corresponding bit in register A can be cleared to 0. Here 0 is there in register B. The corresponding bit in register A is 1. It can be cleared to 0. Here 0 is there. The corresponding bit in register A is 1. It can be cleared to 0. Here 0 is there in register B. The corresponding bit in register A can be cleared to 0. It is already 0. There is no change at all. If any bit 1 is there in register B, the corresponding bits in register A does not change. So here 1 is there. The corresponding bit in register A is 1. There is no change at all. Here 1 is there. The corresponding bit in register A is 0. There is no change at all. Here 1 is there. The corresponding bit in register A is 1. There is no change at all. Here 1 is there. The corresponding bit in register A is 0. There is no change at all. So after performing masking operation, after performing masking operation, register A contains 0 0 0 0 1 0 1 0. Okay. So up to now masking operation is completed. Now we have to perform the OR operation. Okay. So after performing masking operation, what is the result we are getting? 4 zeros, 1 0, 1 0. After masking, register A. Next one, here 1 0 0 1, here 0 0 0 0. So register B contains this one. Register B contains this one. It can be called as logic operand. Now we have to perform the OR operation. Okay. So 0 plus 0, 0, 1 plus 0, 1, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, that is 1. So this is. So after inserting 1001, register A contains 1001 1010. Okay, so here this operation is called as masking operation. This operation can be called as OR operation. So insert operation is nothing but combination of masking operation and OR operation. After performing masking operation, this is the result we are getting. With that result, we have to perform the OR operation with logic operand. Then we are getting this is the result. So after performing insert operation, this is the result we are getting. This result and this result both are equal. Okay. And last operation, sixth operation is clear operation. Clear operation is nothing but when both the bits in register A and register B are same, then we have to put the 0 in the result. Okay. Register A contains 4 bits, register B contains 4 bits. The corresponding bits are compared. After comparing, both bits are same, then we have to put the 0 value. Okay. So how do it perform? Suppose register A contains 1010. Before performing clear operation, register B contains 1100. So this is logic operand. Now, how to perform the clear operation? To perform the clear operation, the corresponding bits in register A and register B are compared. Okay, here register A contains 0 bit, register B contains 0 bit. The corresponding bits are compared. If both bits are same, then we have to put 0 value. Next, here 0 is there in register B. Here the corresponding bit in register A is 1. Both bits are different, then we have to put value 1. Next, here 0 is there in register A, here 1 is there in register B, the corresponding bit. Both bits are different, we have to put value 1. Next one, here 1 is there in register B, the corresponding bits in register A is also 1. Both bits are same, we have to put 0. Okay, so if both bits are same, then we have to clear to 0. If both bits are different, we have to put 1. Okay, suppose another register A contains 1010. Register B contains 1010. Now comparing the corresponding bits. Here Register A contains 0 bit, register B contains 0 bit, both bits are same, then we have to clear to 0. Register A contains bit 1, register B contains bit 1, so both bits are same, we have to put 0. Here register A contains 0 bit, register B contains 0 bit, both bits are same, we have to put 0. Register A contains 1, register B contains 1, both bits are same, we have to put 0. If both bits are same, we have to clear to 0, that means we have to put 0. Both bits are different, we have to put 1. Okay, so after performing clear operation, register A contains 0, 1, 1, 0. So this is the clear operation. Okay. Selective set operation behaves like a logical OR micro operation. Selective complement operation works like a exclusive OR operation. Selective clear operation works like a and B complement micro operation. Mask operation can behave like a logical AND micro operation. Insert operation works like a logical OR operation. Clear operation works like a exclusive OR micro operation. So these are the 6 applications of logic micro operations. I hope all of you understanding this video. If you really understanding this video, please click on the like button and share this video to your friends and classmates. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. If you really like this video, please subscribe my YouTube channel. So DIVVELA Srinivasa. For better understanding of computer organization and architecture course, go to this channel and go to the playlist called Computer Organization or Computer Architecture. It contains approximately more than 140 videos. Watch this video and understand the entire course. Thank you one and all for watching this video.